jump to part C. Excuse me. So part C says, find the x-coordinate of each point at which graph of G has horizontal tangent line, right? So horizontal tangent line. Be careful with G, it's not a F, which is here, but it's G. For each of these points, find whether G has relative mean, max, or neither, right? So from this x-coordinate we found, we have to find if it is relative mean, max, or neither. So before we begin, let's jump into the really basic concept of calculus. This is not a concept of calculus, but you have to know this. This horizontal tangent line. This horizontal tangent line, I'll just abbreviate this, tangent line. Its slope always equal to 0. Always equal to 0. That is the definition of horizontal tangent line. The slope always equals to 0. Because it is horizontal, it will be slope will be 0, and because it is tangent line, the point will only one point will touch each other, right? Let's use this equation again. According to the part B we use this equation to do second fundamental theorem of calculus, right? As you can see, when we derivative each side, this will be g prime x. And this will be, by the second fundamental of calculus, f of x, right? As you can see, g prime x is equal to f of x, like part B. And we said, horizontal tangent line, the slope is always 0. What did I tell you in the part B? The prime function tells you the slope. And we want, because it is g has a horizontal tangent line, we want its slope to be 0. That means because g prime x is equal to f of x, this is so mazy. This will be 0, right? Do you get it? So because g prime x is equal to f of x, and g prime x has to be 0 because the problem asks us to find x coordinate that has a horizontal tangent line, which slope is 0. That's why the f of x is also 0. Let's find the point. This has 0 and this has 0, right? And before that, we have to check. Even though we have 0, there could be tangent. That is tangent line. First of all, that is tangent. That makes the tangent line. So first part, because there are two questions here, find and for each determine, right? So there are two questions. So we first found at x equals to -1, right? -1 and 1. I'll write more neatly. Negative and 1. G of x has, I'll just abbreviate this, but do not do this in the test, the horizontal tangent line, right? So the second part is, for each of these points, determine whether g of g has relative minimum. Let's just draw a random graph. I will just draw a parabola, and let's say this is graph of g, right? Okay. So this is g of x, not g prime x, but this is g of x. So for this, change the color. What is this point? As you can see, as it goes up, it reaches this point and it goes down, which is maximum. On the other hand, when the parabola is looking like this, sorry for being messy, what's this point? As it goes down like that, it reaches the bottom and goes up again. That means this is minimum, right? So using this, oh, one more thing. This is another important thing. I just erased the problem itself. So one more thing. One more thing is this. What if the graph was like this? We can see as it goes up, it reached the slope. Let me be clearer. As it goes up, slope becomes 0, right? And then goes up again. This part, the slope is 0. However, that could be tangent line. However, it goes up and it still goes up, right? It goes up and still goes up. So, like this, it goes up and it still goes up, right? That means this is neither a maximum nor minimum, right? And now, second concept. From this, for maximum, as you look at the slope, as it goes up, the slope is positive. And after hitting the maximum, it goes down, slope is negative. Again, from here, sorry about that, from here, it is minimum. As it goes down, negative, touches the bottom, positive, right? So when you look at the maximum, you'll find positive. You will find the slope changing positive to negative, and for minimum, you'll see slope changing from negative to positive. So looking at that, in the part C, it says whether G has relative minimum or relative maximum, or neither, right? We found 2 points. X is equal to, right, this little negative 1 and 1, right? Negative 1, because it's graph of f. What does graph of f equal to? The slope line of g of x. So this is slope line. X-axis, above the x-axis is positive, below the x-axis is negative. Above the x-axis, this line is positive. Below the x-axis, this is negative. Now, let's look at 1. 1, this line, do you see this line? It is negative because it's under the x-axis. And after hitting this point, after hitting this 1 point, it's still going down, right? I mean, it's still... No, I'll be clear. Sorry for that, take that back. It is still under the x-axis. So it is still negative, right? So, in this point, negative 1 changes from positive to negative. Positive going... Oh, sorry about that. Positive going up. Will be more... Positive going up, negative going down. This will be negative 1. And from here, it's negative to negative, right? Going down, going down. Negative, negative, right? Positive, negative, negative, negative. So, that means, what did I say previously? Positive to negative, maximum. So let's jump to 1. Like I said, because both lines, I'll use different color. Both lines here is under the x-axis, right? So thus, the graph will somewhat look like this, which doesn't have neither maximum or minimum. We can say this part, the parenthesis part, will be answer for the first part, find part, and these 2 arrows, by proving negative 1 is relative max and x equals to 1 is neither min or max, is the second part, determine whether, right? So there are 2 parts for this question, this part, and then we just answered all. Let's jump on to part D, finally. So, part D says, for exclusively between negative 4 and 3, find all the values x for which graph of G, I circled it, G has point of inflection. So, let's quickly review this. F double prime contains the thing called point of inflection. Point of inflection is where the concavity changes. So if I draw this graph, at this point the concavity changes because, as you can see, there are 2 concave types. Concave up, as in up, sorry for making that joke, and concave down. From here, concave up and concave down, right? That's why at this point the concavity is changing. So let's jump onto the question. We need, because the question asks for point of inflection, we need to use G double prime and F prime for this particular question. So before that, how do we know where the point of inflection is? So for you to know point of inflection, so in this case, let me redraw that. In this case, because we're just playing with G, this will be concave up because as in up, positive, G double prime is greater than 0 and G double prime is less than 0, concave down. And that this point 0 will be the point of inflection, okay? Then you'll think, but we only know this, right? So we only have graph of f, so what should we do? Let's convert this. So G double prime x is equal to f prime x. So what does f prime x do? It shows the slope of a function. So for it to have concave up, G double prime x has to be greater than 0. That means f prime, substituting in, f prime x has to be greater than 0. Let me count all the positive slopes. This is positive, right? For it to have concave down, G double prime has to be less than 0. f prime x has to be less than 0. F prime x is slope. So slope. This is going down this way, right? So it's negative. Again, this time, this negative. And this time again, negative. Now it's our job to just find the answer. Let's think simply. Again, point of inflection has to be that 0 point, right? That 0 point where it's like this and changes the concavity, right? So it should be either concave up to concave down or concave down to concave up, which is greater than, while it was greater than 0, it all of a sudden touches 0 and becomes less than 0, right? Greater than 0, positive, touches 0 and comes down, right? Positive to negative. So this point will work. Put here. This is negative, right? This is negative to negative, right? Negative to negative, it doesn't change the sign, so it stays still, so that is not a point of inflection. However, from this one, negative to positive, right? So this 0 will be point of inflection. And now, we have positive to negative, right? Positive to negative. So the sign changes, right? So sign changes. Positive to negative, sign changes. So this point works. So let me finalize the points. This point, and this point. Let's write that down. This is -1. This is -2. This is 0, obviously, origin, and this is 1, right? So we've until now have found 3 points of inflection, and that is the answer. So in the question it says explain your reasoning, so you must explain it. So in complete sentence, the graph, this is your complete answer. If you have any question, please comment below. If any concept explanation was unclear, please comment below so I can edit the video. And also, if anything is unclear to you, please comment below, then I will connect to other videos that I made that explains that concept. So thank you very much for watching this video, and I hope this video was helpful. Thank you. See you next time.